Redox reactions are not always something that we want to have happening. Corrosion is a redox process that destroys metals, it oxidizes metals. Most metals do undergo some corrosion. The most common kind is the rusting of iron. So here's the half reactions for the rusting of iron. We've got iron going to iron ion, and the oxygen and water are forming hydroxide, and we end up with an overall reaction that's generating iron hydroxide. The iron hydroxide goes on to react and form Fe2O3, which is that familiar crumbly, rusty stuff. So the Fe2O3. The main reason that iron rusting is such a big problem is that Fe2O3 is very crumbly and it falls off of the iron, exposing more iron underneath that rusts as well. And so if left unchecked, it can actually just completely eat up a piece of metal until there's really nothing left. Other metals like copper and aluminum oxidize as well, but here the oxidation product sticks to the metal, and so it ends up serving as a protective coating and keeps the metal from oxidizing any further. So if you've got a penny in your pocket and you pull it out, it's probably, if it's an older penny, it's not shiny and coppery looking anymore. It's got kind of a dull finish on it. But it'll stay that way for decades, for hundreds of years, because the oxidation product on the outside is tough and it stays there. And so it does not eat it all up. Iron oxide doesn't do that. So preventing rust is a big deal, and people have found numerous ways to do it. One of the important things is keeping iron dry, because if you don't have any water present, you can't have any rusting. It's hard to keep iron dry, though, because even if it's just open, exposed to the air, there's some water in the air and some rusting will occur. One way you can protect it from water is by painting it or putting some sort of a sealant on it. So paint does a great job, but if you get a couple of scratches that expose the iron underneath, it starts rusting. So here's a picture of what can happen. I grew up in the Midwest where they salt the roads in the winter to keep people from sliding off into the ditch and killing themselves. But it does a real number. Another thing you can do is place what's called a sacrificial electrode in contact with the iron. And so here what you're doing is you're taking a more reactive metal, connecting it by a wire to the iron you're trying to protect, and that more reactive metal will oxidize instead of the iron, and so the iron will remain intact. Another thing you can do is actually coat the iron with a more active metal. One of the processes is called galvanizing. You've probably heard of galvanized nails. If you're building a fence, you want to use galvanized nails, because your fence is going to be out in the rain, and you don't want iron nails just rusting away. So they coat them with a thin layer of zinc, which is more reactive. The zinc oxidizes, but the zinc oxide sticks to it and doesn't go away, and so then the iron underneath is protected and the nails will last much, much longer. So electrochemistry is what all this is, and it's very, very useful. And that's the end of the chapter.